No time ticked. No space stretched. No matter moved. There was only potential. Then, from this boundless void, came a moment beyond human comprehension. It wasn't an explosion within the universe. It was the universe? A singularity, an infinitely small point, denser than anything we can imagine, holding within it the entire future of reality, suddenly expanded. This event, now known as the Big Bang, didn't happen in one place, it happened everywhere at once, for there was no space as we understand it before that moment. Space unfolded. Time began. Matter took its first breath. What followed was a torrent of heat, light, and raw energy. From this chaos, order slowly began to emerge. The universe cooled, and with cooling came structure. Elementary particles formed atoms. Atoms formed clouds. Clouds gave birth to stars. And stars gave birth to everything else. We are the children of this process. Forged in the hearts of dying stars, scattered across space by titanic explosions. Our atoms, our bones, our thoughts, are built from stardust. For over a century, this story has served as the foundation of modern cosmology. The Big Bang theory became the lens through which we understood the cosmos, supported by the faint echo of radiation that still lingers, the cosmic microwave background. Then came the Hubble Space Telescope. Orbiting far above Earth's atmosphere, it gave us glimpses of galaxies scattered across the night like cosmic confetti. It showed us how vast, how ancient, how incomprehensibly diverse the universe truly is. But even Hubble had its limits. Then came its successor. A new eye. A golden sentinel drifting a million miles from home. The James Webb Space Telescope. Unlike Hubble, Webb does not peer in visible light. It sees the universe in infrared, in the stretched remnants of ancient photons, light that has traveled for over 13 billion years to reach us. Webb sees not the universe as it is, but as it was. And what it sees is not what we expected. In image after image, Webb revealed something astonishing, galaxies that existed when the universe was young. Galaxies that should not have been there, not yet. Not so many. Not so fully formed. They were supposed to be messy, chaotic, disorganized. But they were elegant. Spirals. Disks. Complex structures, serene and balanced, seen at a time when the universe was still learning how to be. These galaxies were smaller, yet complete. Their light was ancient, yet mature. Their order defied the predictions of our models. It was as if the universe had grown up too fast. And they weren't few. They were many. Far more than the theories allowed. Hundreds. Thousands. Dotted across the sky like silent secrets, waiting to be found. Scientists were stunned. The models did not predict this. They could not. One headline read, "Panic. Webb's galaxies shatter the timeline of the universe." It wasn't an overstatement. These findings cracked open the core assumptions of modern cosmology. Because if these galaxies are real, and they are, then everything from the age of the universe to the nature of dark matter may need to be rethought. One of the most confounding discoveries was the sheer smoothness of these early galaxies. According to the Big Bang model, galaxies in the early universe should bear the scars of violent mergers and collisions. They existed just a few 100 million years after the Big Bang. And yet, their structures were too sophisticated for their age. It was as if we'd stumbled upon a baby born fully grown. This smoothness, this order, challenges the idea that galaxies formed slowly over billions of years. Instead, it suggests that some galaxies may have formed rapidly, almost instantly, after the Big Bang, or perhaps, they formed in a way we don't yet understand. And then there was the matter of size. These galaxies were too small, too compact, for their brightness. Some appeared to be bursting with stars, far more than should have existed at that epoch. And yet, they looked dense, tight, and self-contained. This presents another problem. According to the standard model of cosmic expansion, distant galaxies should appear larger due to the way light stretches in an expanding universe. But these galaxies appear smaller, more compact, like they're defying the very fabric of space. This raises a profound question: is the universe truly expanding the way we think it is? Could our understanding of cosmic inflation be incomplete? Could there be factors at play we've never considered? Some now speculate that dark energy, the mysterious force thought to be driving the accelerated expansion of the universe, may not behave as we've assumed. Others wonder if dark matter, the invisible glue holding galaxies together, could be something far stranger than we imagined. Still others are going further. What if the Big Bang wasn't the beginning? What if it was a transition? A rebirth from a previous universe, collapsed in on itself, only to explode outward once again. A cyclical cosmos, eternal, rhythmic, and unknowable. This idea is not new. Ancient cultures spoke of cosmic cycles, of universes being born and dying like the seasons. Now, modern physics is beginning to catch up. Some theories suggest that before the Big Bang, there was another universe. A contracting one. That what we see now is just the latest breath of an eternal lung, inflating and deflating across eons. Others propose a multiverse, countless universes, each with its own laws of physics, born from quantum fluctuations, bubbling endlessly from a boundless source. What if the James Webb Space Telescope has seen not just deep into space, but sideways into another reality? What if those galaxies aren't early, but other, new, parallel, unconnected to our origin story? Speculation, perhaps? But isn't that where all great discoveries begin? With questions. With the willingness to admit, we do not know. That is where we are now. Standing at the edge of known science, staring into the abyss of possibility. James Webb has not just provided images. It has stirred a revolution. It has forced us to confront our limitations. To admit our ignorance. To challenge the stories we've told ourselves. And that is beautiful. Because in science, questions are more powerful than answers. In questions lie the seeds of discovery. In awe lies the beginning of understanding. And so, as we stare at the glowing spirals and delicate filaments of these ancient galaxies, we are reminded of our place in the cosmos. Tiny. Curious. Ever-reaching. The universe may be far stranger, older, and more complex than we ever imagined. And that is exactly why we must keep looking. Because every new image from James Webb is not just a picture.